This short movie presents the so-wanted pattern of prime numbers distribution, unless, the simplest one, since the sieve of Eratosthenes. The mathematical prime notation allows us to understand how primes are distributed in relation to composite numbers, although, all of them being elements of the same sets, as integer, as rational, but always primes. The mathematical notation of the prime set came from the calculus thoughts of differential, however, applied to sets. The illustration of how to distribute primes arithmetically is given by the Venn diagram, and its law of inclusion-exclusion, as well, the Pythagorean table generated. Such, given two identical sets A and B, composed by the positive integers greater than 1, as in the following notion. A and B, greater than 1, belonging to the integers set. And a third set, C, equals to A times B. The product between integers greater than 1. And then, the inclusion-exclusion principle. A minus A union C, where A union C equals to A plus C minus A intersection C. The notation, bellow, is reduced to prime set is equal to A minus A intersection C. Too hard to understand? The Pithgurian table, according to the prime notation, is the tabular values given by the product between each element in A by each element in B. So the respective values populated the table by A times B. A intersection C. The intersection, composites, in red. Following, the prime notation and the inclusion-exclusion principle. The prime set is equal to A minus A intersection C. In green, all primes, until the limit of A and B, equal to 10. The notation extends until infinity, because the prime numbers cannot be written as a product between two integers greater than 1. However, to reach biggest prime numbers is necessary to distribute all composites until the respective magnitude minus 1, which is the number of elements in A and B. The solution for this divergent operation between sets is to find a function that makes the convergence to all primes. One of the possible derivations is congruent with the Riemann zeta function at zeta 2. Then, observing the exponential growth of the square table through the diagonal, where lies the autovectors or eigenvalues, which are all integer squares, denoted by C is equal to the autovectors of A times B. And considering the autovectors of its inverse table, C is equal to the autovectors of A divided by B, which is an infinite succession of ones. Then, zeta 2 is equal to 1 plus the infinite summation of the integer squares reciprocals, that converges to the square of pi above 6. As in the following expansion.
Challenge. Can you account the primes until 10 to the power of x? Conclusion. Solving the challenge. Based on the prime notation, the rules of the Pythagorean table, and its exponential growth throughout the diagonal, autovectors, is given the ring of integers. Hence, in log rule, the logarithm of the square roots of the autovectors implies in n. Such is inferred that the prime counting function implies in the following integral, where c is an arbitrary variable n greater than 1 belonging to the integer set. and x being the magnitude. The limits, inferior, a equals 1. Superior, b equals x. Although being divergent, it is one of the possible prime counting functions. However, it demonstrates more accuracy than the prime counting theorem and the integral logarithm of x, based on the asymptotic law of prime distribution. The deviation appears from the superior limit, at the order of 10 to the power of 4 and is represented by the negative square of the logarithm, base 10, of x plus c. The solution of this prime counting function integral is given by the summation of the reciprocals of the logarithm of n, until the superior limit x, plus its respective deviation. Thanks for watch.